empty Power BI project. So an empty Power BI project is just the empty software. So you will launch the software. And once you have the software launched, what we will do is we'll go ahead and click on blank report. A blank report is just an empty project that you can, let's say you can shape in any way you want. It's very malleable. You can start from other projects as well, or you can start from other starting points. For example, you can start with Excel, or you can start with a SQL Server, or any form of data source that you have. So we will start, let's start with a blank report. By starting with blank report, now we can have many things that we can do. But the first thing that we usually do is we go ahead and start saving the project. So we will go ahead and save the project anywhere you want. So let's save it on desktop. Let's call this project from Access. Okay, Power BI, the good thing about Power BI, and to be honest, I always get surprised by the strength of Power BI if compared with other alternatives that are paid. Power BI has the capability to load more than 100 types of data. This is including the data that comes from Python connectors. If you want to load any type of data, we usually get data and then go to more. And for this example, I would be loading data from Access. So Microsoft Access is actually a database provided by Microsoft Office package. This Access database acts as a regular database, but it's contained in a single file and it's usually installed on a computer. So let's go ahead and click on Connect. And now Power BI will ask you, where do you find this database? So let's go ahead and search for the name of the database. So the database is called Vault Database MDB, which is short for Microsoft Database. And we will double click on that or click on Open. And once we click on Open, what will happen is the Access database contains multiple tables. This is a regular Access database. So in Power BI, each database, or sorry, each table in Access will be translated into a single table in Power BI. So we can have one-to-one mapping, meaning that one table from Access will be equal to one table from Power BI. And this is the beauty of Power BI. You can just load a single table and everything will be okay, or you can just go ahead and load everything. So for the sake of this example, we are going to check everything. By the way, once you check something, meaning that you're trying to load the full table, so the full table will be loaded. If you want to load like partial table or a portion of the table, what you need to do is after you load, you go ahead and transform the data. That's why the initial step in Power BI, it's known as ETL, which is exploration, transforming, and loading. Let's select all the parameters and all the tables we have. And by the way, once you click on a given table, you'll see that there is a snapshot of that table viewing up, and you can just explore the data. Of course, it's not going to be fully viewed, the table, because Power BI, what it does, it only shows you few rows or tens of rows, at least in the case of large tables. Why is this? Because they want to save RAM space. That's why they are not showing you everything. So once we have those, we will click on load. We will wait for a few seconds. It can go up to a minute if your PC is a bit slow, but at the end, everything will be loaded up. There we go. Now we will get a nice loading report. And after that, we will get all the tables are showing up on the right-hand side. Okay, so first of all, let's start doing few practices. So the first thing that I will do on the first page in the dashboarding, or let's say in the Power BI, I will add a welcome page for the user. So the user can know the basic metrics about this business. And of course, this business is just a oil and gas field that contains all the parameters for upstream. Plus, you can have all the parameters for downstream and midstream. Plus, I have seen people who use this for project management as well. Power BI is a very flexible tool. It can do many things, and it can actually work in any way you want. So, for example, what we will do is, first of all, let's explore the data. So we will go ahead and go to table view, and from table view, we can explore the data. The data actually, this data set does not contain many wells. This is coming from Wolf field from North Sea. So that's why it only contains 7 wells, but some wells are injectors and other are producers. So what we will do is we will create a bar plot or a bar chart that shows you the names of the wells plus the depth of those wells. So we can give this as a basis of comparison between those wells. Let's go ahead and add a bar chart. And the bar chart usually requires 2 inputs at least. So the first input is actually the x-axis. Usually in bar charts, in x-axis, we will have categorical data. And categorical data means anything that's related to names, field names, well types. So those are basically categorical data. For this example, what I will do is I will have the names of the wells on the x-axis and the depth of those wells or the target depth of those wells on the y-axis. So this actually shows us how deep each well is. We can see some wells are very comparable in depth. But if you pay close attention to this chart, actually this chart does not represent the actual depth or let's say the actual representation of the depth. Why is this? Because in oil and gas industry, what we are used to is actually we're used to seeing the depth as the 0 or the mark 0 is on the top and the depth or the maximum depth we reach on the down. So let me show you what I am talking about. So basically, in oil and gas industry, the representation for the depth, usually this is the mean sea level or any type of depth reference that we're using. So let's say that this is mean sea level. And usually the wells that are penetrating usually will start at 0 location and then they will go as deep. Okay. So, and if you want to compare multiple wells at the same time, so your chart should look something like this. Okay, but the chart that we have created in Power BI actually does not look like this. Why is this? Because in Power BI, usually the chart starts from 0 and goes upward. In oil and gas industry, it starts from 0 on the top and goes downward. So what we need to do is we need to adjust for that. So how can we do this? The first thing that we will do is actually we will select the chart and then format our chart. And then we will go to y-axis. Once we select the y-axis, we will activate an option called Invert Range. So we will click on Invert Range. We can see now the depth are aligned correctly now. And the wells names are showing on the x-axis and the wells are showing on the y-axis at the depth. We can just resize this to any size we want. Before we proceed any further, so let me show you what else we can do. We can also change the title for this. So you can activate the title or you can change the title altogether. So let's call this depth. Let's call this depth chart and make sure we center everything. There we go. It looks good. And one final thing is actually from this data, we know that we have some wells are producer and others are injector. But in this depth chart, actually nothing is distinguishable. All the wells have the same color. First of all, usually what we need to do is we need to set up a relationship between the tables. But for us, by the way, this data set, it was just a single table. I broke down this data set into multiple tables and I did all the things I can do in order to make this a proper data set. So that's why the relationships, now do you see those relationships? This is known as a Snowflake relationship. This relationship is actually set up automatically by Power BI because I did everything correctly. That's why it detected those relationships. If for some reason you don't have any relationships, for example, like these two tables, they do not have any relationship, you can, of course, create those relationships manually. But for our example, you should have relationships for this trick to work. So what I will do is I will color those bars based on the type of the well. So how can we do this? First of all, we need to make sure that those wells are the names of the wells are connected to the categories or the type of the wells that we have in other tables. So that table will be categories. In categories, if we explore categories, we will see that this table contains a column called type. By the way, this column can be anything you want. I have seen even people putting type as integer values, for example, 0, 1 to 3. This is also possible. Some people will only have letters for this. For example, some people will have the letter O capital, meaning that this is an oil producer. Some people will have WI, meaning that this is a water injector, but you can just make this abstract or you can go full in details. It's all up to you. So what we will do is we will drag and drop type. We are not going to drag and drop the type on top of the chart. No, we will going to drag and drop the type to the legend. Once we do that, now two tables are contributing to a single plot. And basically what happens is the main plot will be rendered from the base wells, and then the type of the well, or let's say the type of the equipment or the asset, is being pulled from the categories. So bottom line, two tables are contributing to this single chart. Okay, so what can we do else is actually we can set those colors to be proper, and we will go to format visuals, and we will go to for example, we can go to grid line. We can turn on or turn off grid lines if you like that. We can go to columns, for example. We can change the colors of the columns. For example, let's make the oil producer as green. And I think this is too bright. Let's make this darker. There we go. Let's make the water producer as the light blue or a bit lighter than that. There we go. So basically what happened now is actually we have successfully formatted this chart to our likings, and it's representing what should we have, something similar to this in oil and gas fields. Okay, so this is the first part. Usually what we will do is in these types of screens where we have like welcome informations and basic metrics of our business displayed, and usually those metrics are static. What we can do is we can add a summary table to this. For example, we will add a table next to this, and this summary table will have like the basics of your wells. What we can do is in this table, we can add any information we want. For example, we can add the name of the well. We can add the target or the total depth. Next to that, we can have the water depth because this is an offshore field. That's why it has this water depth. Plus, we can have the longitude or the latitude. We can have all of these. And once we do these, this is actually a summary of our data that's being viewed on the right-hand side, or sorry, on the left-hand side chart. Okay, so you can also change the type of the depth, for example, from average to summation or summation to minimum or maximum. All of these are possible. What next we can do is we can view more information about this data. We have a table called rock properties. This rock properties actually contains all of the rock properties from different core samples from these wells. So 7 wells, we have 7 different rock properties. So let's go ahead and create a simple table for that. So I will add one more table. And in this table, I will make sure to populate rock properties. So the rock properties, first of all, I will start with the well name, and then I will choose the shale volume, the porosity, the water saturation, and the permeability. Okay, so basically we will choose all of these. Let's make sure that we have a title displayed for this. from general, we activate the title, make sure that the title is given a name. Let's call this petrophysical properties. There we go. Now these are the physical properties. So the good thing about this, what you can do is you can drive a statistical analysis from this table. So what does this mean? Meaning that if you want to calculate the original oil in place or any parameter that you want that's related to the subsurface and the reservoir engineering, you can do from this. Why is this? Because Power BI gives you the power to calculate all the aggregations. For example, if you want to calculate let's say the shale volume or the average of the shale content for all the wells as a summary, what we can do is switch the summation of the V shale into an average. Now in the totals, we have an average. So an average V shale we have is 0.22. So that's 22%, given this that this is a linear V shale calculation. On the porosity, we can see the Power BI already summed the porosity for us, which is not correct. We should have the porosity actually averaged out, or we can return back the minimum, maximum porosities. Let's switch the porosity to, for example, let's say the minimum porosity, which is 0.19. And for the water saturation, let's say that we are going to take the maximum in our considerations. And the permeability, of course, we have many permeabilities. Let's say that the permeabilities are averaged out, and we can have 984 permeabilities, millidarcies, which is a little bit too much, but these are the data that's coming from the field. What you can do next is, based on these values that you can get, knowing the area and knowing the pay zone thickness, plus, by the way, we already have the pay zone thickness that we can also add. This is the pay zone thickness. What you can do is you can even go ahead further and create something called a measure. A measure in Power BI is just a single number that you can use in order to calculate some given parameter. And based on those aggregated values or those statistical analysis values for porosity, water saturation, and the total thickness or the total pay zone thickness or the average pay zone thickness, what we can do is we can actually calculate the original oil in place using these parameters. Of course, you can calculate the original oil in place using sensitivities as well, by using the minimum, maximum, or the average values that are coming from this table. Okay, so basically Power BI is so flexible. You can do lots of things with this. One more thing I will do is I would add a base map in this that basically show me the location of these wells. So a base map is nothing but a scatter plot. You can also create a base map using the satellite map, but for me, scatter plots are more than enough. So in order to create a base map, what you will do, you'll go ahead and click on scatter. Make sure that you size this to your likings. Let's size this. And in the x-axis, actually, what we will have, we will be having the location for the well for the x and the location for the well for the y. And make sure that these are not set to sum. These are do not summarize. Why is this? Because those are the locations of the wells. There we go. Now this is how our base map is looking like. If you want to add more details to this, what we can do is you can actually drag and drop the total depth and make sure that the total depth is actually the size of these bubbles. Now, the size of these bubbles are denoting the depth of this particular well. This is one of the things that you can do. One more thing that you can do is actually you can add the categories or the type of the well. You can add that on top of legend. Now you have two different colors, and you can distinguish where the locations for those wells are. One more thing that you can do is, once you set up your project the way I did, actually now you're eligible to do a cross filtering. So what is a cross filtering? A cross filtering is basically is an interaction that you do on one graph or one chart, and it basically reflects on the other ones. So for example, if I select this injector well, basically what it happens, all the other parameters, all the other charts and tables will be updated. You can, of course, press Control on your keyboard and select two wells. Now I am only selecting the injector wells, and we can just display the average porosity and the average shale volume that are basically on these injector wells. You can select many, many wells you want. Of course, you are not only going to stop at this area. What you can do is also you can add more depth and more details to this. So for example, what else you can do is you can add or you can change, of course, you can change the colors of these bubbles as well. You can, of course, control the colors of these bubbles, and you can control the size of these bubbles. You can make them larger and you make them smaller. So basically, this is going to be the first page, which contains all the basic informations about our business. This, of course, can be expanding much more than this. I will show you something else that's a bit different than that. Now, you can see this dashboard, or let's say this miniature dashboard that we did. Actually, this contains all the information of our business. Now, what happens if you want to view only a specific part of your business? Maybe you want to view only oil producer or oil injectors only, water injectors only. You have two options for this. Either you activate the filtering and slicing, or you can do something else, which is going to be much more powerful than slicing, which is the ability to create something called DAX expressions. So basically, what is DAX expressions? By the way, DAX expressions will be covered extensively in the training. DAX expressions is the main language that the Power BI uses. Using this language, what you can do is actually you can create very powerful scripts that can do some form of advanced filtering and some form of advanced calculations for you. So let me just show you an example. So the simplest thing that you can do in DAX is basically you can filter a table based on a given parameter. So let me just show you. So let's say that we want to filter the, for example, the categories table based on the type of the well. So what we will do is we will use a function called filter. By the way, there are hundreds of functions that are supported by DAX. And now for the filter, we need two inputs. So the first input for the filter, let's call this, we want to work with categories table. And the next input is actually an expression or a filter that we want to apply. So let's say that we only want to get the wells of a type equals to, let's say, water underscore injector. So once we do that, once we write this script, this will do, this will generate a new table for us. We can go ahead and save the script as a new table, and every time we open Power BI, this table will get updated, and it will get the recent data. So how we can see the results? We'll click on run. There we go. You can see this is a very powerful single line code that what it did, it generated a new table for us. And that new table only shows the water injectors. So what we can do is we can take this, this expression and go to the table view. And in the table view, we're going to create a new table. Or what you can do, selecting any table, you can just right click and then go ahead and create new table. But for us, we're going to do that from tables, tools. Let's click on new table. And of course, you can name this table anything you want. So let's name this only injectors equals to that particular function or that particular line of script that we wrote. Let's click on this red green check, which is commit. Let's click on this, and there we go. Now our table is generated, and more important than that, new table has been added. It contains all the same columns, but now this particular table only adheres to a particular filter that we applied. This is another approach to filter your table. And this approach is so powerful, it's not affected by other filters. So this is something else that you can consider. If you go to relationships, you can see that there is only injectors wells that is already created. By the way, you can also go ahead and create a relationship for this by drag and dropping the common name and then click on save. By the way, the relationships are covered extensively in the training. So these are one of the basic things that you can do. What else we can do is we can also do some operational parameter viewing. For example, what I can do is I can create a line chart. And that particular line chart, for example, it can show some operational data, some daily operational data. For example, let's say the downhole pressure. We're going to do a plot with the date. There we go. This is the downhole pressure. Of course, this downhole pressure is now representing the full field. Why is this happening? Because we did not provide any filtering or any slicing. Now we have many, many options to break this down. Either we break this down by well name. We will add well name to these legend. So it breaks this down. Or what we can do is we can add a slicer with the well names. Basically, whenever you select a well name, you will get this graph updated. One more thing that you can do, or one more option that you can do with this, is actually convert this plot or convert this chart into something called trelli or a small multiples. Basically, what is this is basically is each well will have its location in the chart. So basically, if you have 10 wells, your chart will be divided into 10 small cells to accommodate the position for each particular well. How can we do this? We'll basically drag and drop the well names into small multiples like this. Basically, this is what you will get, or this is the effect you will get. The date is common between all of these charts, and basically what we are getting all of these things from our chart. Okay, so this is one of the examples that we have. One final example left that I can show you related to data analytics is actually how we can implement the clustering action in Power BI. So let me just open up the project for that. Okay, so this is the data from yesterday, and let me show you what this data looks like. If we add a table like this, and then in this table, let's say that we want to plot, or let's say we want to view the gas rate, the oil rate, and basically we want to see the water as well. Of course, we need to explain this by adding the name of the well. Otherwise, this is not possible. There we go. Each well has its own production parameters, something like this. What we can do is actually we can convert this into a k-mean clustering problem. So what is a k-mean clustering problem? K-mean clustering is a machine learning algorithm, which is known as a distance-based algorithm. So what does this algorithm does is basically it finds a pattern or relationship between all of these parameters. For example, it can classify, or let's say it can group your wells, or it groups your equipments based on any parameter that you want to train. So for now, we have all of these parameters that we can feed to the model. But before we feed that to the model, what we can do is we can add the date as a filtering action. Because I don't want to provide all the dates. This is usually done date by date, so one date at a time. So let's select the date. And of course, any delete you select, it's basically the table next to it is going to be filtered on that particular date. Okay, so let's go ahead and write a simple Python code that accommodates for this k-mean clustering. By the way, k-mean clustering or any type of machine learning algorithm is only supported through Python. So it does not exist in Power BI natively because these types of algorithms are really complex and it's not very easy to implement directly into Power BI. That's why they allow you to do so by using Python. And the good thing is actually it's simple and it's not that hard to do. Let's add Python. Once we add Python to this, Python will require you to add what columns that you want to work with. So let's say that we are actually working with oil. We're working with, let's say, gas. And we're working with water. And make sure that you add the name of the well next to that. Let's make sure that we are not summarizing anything. So basically, we're getting only the actual values without any summary. So once you do that, now you'll start typing your code. So the first thing that you do is actually you will start by importing the sklearn library. Once you do that, next, what you will do, you will start importing the plotting library. And we're almost done. So the only thing that we need to do is we need to create the model. So the model will be CLT dot k-means. This is the model. The model does not take anything. The only thing that you can do is you can actually start training the model. So model dot fit. So basically it requires a value for X. So X usually equals to anything that you want to train. For example, data set is basically those data that are coming from Power BI. So let's say that we want to train this based on oil, and maybe you want to add gas. Of course, you can also add water to this. By the way, these types of analysis, usually you omit the name of the well. The name of the well is only there as an indication. Once you do that, and once you pass that into a fitting model, what you can do is you can, after fit, you can get all the predicted labels or the predicted groupings. For example, you can say that I want to group my assets into 3 groups. And basically, k-mean clustering does that depending on the statistical calculation and based on the distance algorithm that it has. Once we have that, we will create a variable called labels. And that labels variable is basically coming from models.labels. Basically, this is all you need to do in order to calculate or basically create a distance-based clustering algorithm. Once we do that, it's basically, we will plot the labels against the X and Y in these types of situations. So yeah, basically, this is how you can do a clustering modeling in Power BI. Of course, this can be as complex as you want. Even that, this is basically, this is the simplest that you can go. The first 2 lines does not count because these are just the import lines. The actual lines are those which are, I think, which is fairly good. 3 lines or 4 lines of code that can generate a full-fledged algorithm that you can return back to Power BI. And thank you so much for joining in today's session. That was 2 days webinar. And please, if you have any questions, please go ahead and ask in the chat box. We'll try to answer that. Over to you, Nikhil.